and controlling, tracking progress using key performance indicators and making necessary adjustments. Closure, reviewing outcomes, documenting lessons learned, and officially closing the project. Agile project management methodologies such as Scrum and Kanban have become widely adopted in cybersecurity initiatives due to their flexibility and ability to adapt to evolving threats. Instead of following a rigid structure, agile approaches allow security teams to work in interactive cycles, continuously improving security controls and responding to new vulnerabilities as they emerge. Security teams often work in sprints, where tasks such as penetration testing, compliance checks, and incident response are prioritized based on real-time risk assessments.
The organizational structure of a cybersecurity project depends on its complexity and scope. A well-defined team typically includes a project manager overseeing the initiative, security analysts responsible for vulnerability assessments, compliance officers ensuring regulatory adherence, and network security engineers implementing the technical solution.
Collaboration between these roles ensures that security risks are addressed effectively while aligning with business objectives. Now that we have an understanding of project structures, let's now explore how project scope is defined and how a project plan is developed to ensure success. Clearly defining the scope of a cybersecurity project is essential to prevent delays, misalignment of objectives, and unexpected risk. The scope outlines what will be included in the project, what will be excluded, and what the expected deliverables are. In a security project, this might involve defining objectives such as implementing a next-generation firewall, deploying endpoint protection, or conducting a compliance audit. The scope also specifies success criteria such as achieving full compliance with regulatory frameworks like GDPR or NIST. Once the scope is defined, a detailed project plan is developed. This includes mapping out specific tasks, assigning responsibilities, and setting timelines for each milestone. Security project planning involves creating a work breakdown structure that details threat modeling, security control implementation, and penetration testing tasks. Project managers use visual tools such as GANTT charts to track progress and identify dependencies between different security activities. Risk management planning is also integrated into the project, outlining strategies to mitigate security vulnerabilities and ensure resilience against cyber threats. With the project plan in place, the next critical step is estimating the necessary resources to execute the security initiative effectively. Accurate resource estimation ensures that project has the personnel, tool, and budget to succeed. Security projects require specialized skills, and resource estimation involves determining how many security analysts, network engineers, and compliance experts are needed based on the project's scope. Financial estimation involves allocating budgets for security software, hardware, training, and third-party audits. Security teams often use historical data from similar projects to estimate cost and staffing needs. Advanced estimation techniques such as bottom-up estimation involve breaking down security tasks into smaller components and assessing the required effort for each.
For instance, deploying an intrusion detection system might require network security engineers to configure rule sets, conduct testing phases, and train employees on monitoring alerts.
We will now understand the functions of the audit team and other cybersecurity project staff. A cybersecurity audit team is responsible for ensuring compliance, detecting security gaps, and verifying adherence to security policies. The audit team includes lead auditors overseeing the entire process, security analysts evaluating system vulnerabilities, and compliance officers ensuring that security controls meet industry standards. The team conducts thorough review of firewall configurations, access control policies, and vulnerability remediation efforts to identify weaknesses before they are exploited. Regular internal and external audits help organizations strengthen their security posture by proactively addressing risks. The findings from these audits provide actionable insights for improving security frameworks and ensuring that project objectives align with regulatory requirements. Measuring project success involves tracking key performance indicators that reflect security effectiveness. These include metrics such as incident response time, vulnerability remediation rate, and compliance adherence. Monitoring these indicators ensures that security teams respond to threats efficiently and maintain system integrity. Performance evaluation of team members is equally important. Security professionals are assessed based on their ability to identify threats, implement security controls, and collaborate effectively. Innovation in security strategies and proactive risk mitigation contribute to the overall success of cybersecurity projects. We have reached the end of this module. Successful cybersecurity project management requires careful planning, precise execution, and continuous monitoring. Mastering these skills enables security professionals to drive cybersecurity innovation, mitigate risk, and ensure compliance in an ever-evolving threat landscape.